In this video, we're going to be talking about conditional probability. Conditional probability is the probability that one event occurs given another event has already occurred. To answer the 4 questions, we've been given a two-way frequency table with information about 800 total students. We've been given information about whether students have 0 or 1 sibling or 2 or more siblings, and whether they were born in Maryland or born outside Maryland. Our first question asks about the probability that a randomly selected student has 2 or more siblings. I'm going to start by writing this using probability notation. Remember, for probability notation, we write a P, which represents probability, and then in parentheses, what we're looking for. And we're looking for the probability that a student has 2 or more siblings, and I'm just going to write 2 or more for short. Since we're looking at any randomly selected student, our denominator is going to be our grand total number of students, which is 800. We're looking for the probability that a student has 2 or more siblings, so I need to know the total number of students that had 2 or more siblings. I go to the 2 or more siblings column and down to the total, which is 376. So the probability that a randomly selected student has 2 or more siblings is 376 out of 800. The next question asks for the probability that a randomly selected student born in Maryland has 2 or more siblings. This question is different from the last one. Instead of just randomly selecting any student, we're only selecting students born in Maryland. This is what we call our condition. So this is a conditional probability question. We're only looking at selecting students born in Maryland. To help us focus on just students born in Maryland, we are going to circle the born in Maryland row. So we will only be using numbers from this row to calculate our probability. First, let's write this conditional probability statement in our probability notation. So we write P parentheses. Our condition always comes last in our probability statement. So I'm looking for the probability that a student has 2 or more siblings, that comes first, given, and instead of writing the word given, I'm going to use this vertical line, which represents given. So the probability that the student has 2 or more siblings given they were born in Maryland. The condition being that we're only looking at students born in Maryland always comes after that line or the given. Since we're only selecting students born in Maryland, the total number of students is just the total number of students born in Maryland, which is 336. That goes in our denominator. In the numerator, we're looking just at students who were born in Maryland that have 2 or more siblings. So again, I stay in my born in Maryland row and I go to the 2 or more siblings column and I get my numerator, which is 72. So the probability that a student has 2 or more siblings given they were born in Maryland is 72 out of 336. The next question asks, what is the probability that a randomly selected student was born outside Maryland? This one is asking about any randomly selected student. So the probability that a student was born outside Maryland, this probability is going to be out of 800 because we're selecting any student. And we need to know how many of those students were born outside Maryland. So I go to the born outside Maryland row and over to the total, which is 464. The probability that any student was born outside Maryland is 464 out of 800. For the last question, I'm being asked the probability that a randomly selected student was born outside Maryland given they have 0 or 1 sibling. This question is giving us a condition again, and I especially know that I have a condition because of that word given. So my condition is that we're only looking at students that have 0 or 1 sibling. Since we're only looking at the students with 0 or 1 sibling, let's go to the 0 or 1 sibling column and circle that again. And I like to call this the circle and check method. So I always, when I know I have a conditional question, I circle what I'm focusing on and then I end up checking my numerator. So let's write this using probability notation again. So P parentheses that a student is born outside Maryland given, and instead of using the word given, I use that vertical line, given they have 0 or 1 sibling. So my denominator is the total number of students that I'm selecting from. And since I'm only looking at students with 0 or 1 sibling, my denominator is the total students with 0 or 1 sibling, which is 424. And since I want to know the probability that out of these students, they're born outside Maryland, I stay in my column and I look at the students born outside Maryland, which is 160. So the probability that a student is born outside Maryland, given they have 0 or 1 sibling, is 160 out of 424. Now I'm just going to show you the general conditional probability formula, and then I'll explain how the formula relates to what we already did. So just as a reminder, these two starred questions were the two questions that used conditional probability. In both questions, we wrote with our probability notation, P parentheses, an event A occurs given that an event B occurs. So that's our notation. We use that line to represent given. And in both of these questions, we had the probability of our condition occurring as our denominator. And I'm going to explain that, how we use that in a second. So if you go back to our first starred question, our denominator was the total number of students born in Maryland. That was our condition. So we went to the students born in Maryland and took the total from that row and put it in our denominator. So we always use the condition. Same with the second starred question. Our condition was that students had 0 or 1 sibling. So we took the total from the 0 or 1 sibling row and put it in our denominator. So the probability of the condition always goes in the denominator. So in our formula, that's the probability of B. That's our condition. Then in our numerator, we always use the probability that A and B occur. So if you think back to the first starred question, our numerator was 72. 72 comes from the box where students have 2 or more siblings and they're born in Maryland. So the probability that a student has 2 or more siblings and is born in Maryland is what went in the numerator. Same for the second starred question. We focused on the students that had 0 or 1 sibling and were born outside Maryland. So we took the probability that we were looking for and combined it with the condition to get 160 in our numerator. So that's, if you're looking for conditional probability, you can either use that circle check method we did, or you can use this formula.